Hello and welcome to the Business Analytics Webinar Marathon. We're super excited you could join us today for Ken Raetz' session, Modular Data Extraction and Integration Patterns. My name is Dan English and I have a few quick introduction slides before I hand over the reins to Ken Raetz. Next slide, please. If you require technical assistance, please type your question into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you will want to ask any of your questions throughout the presentation. Feel free to enter your question at any time, and once we get to the Q&A portion of the session at the end, I'll read your question aloud to the speaker. You're able to zoom in and out on the presentation content by using the zoom button located on the top of the presentation window. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear on your web browser. Next slide. If you like what you hear in these webinars today, make sure to attend the past Business Analytics Conference taking place May 2nd through the 4th in San Jose, California, with hands-on learning opportunities from data and business analytics experts and a variety of networking opportunities. The past Business Analytics Conference is a great opportunity to gain valuable skills and advance your career. All webinar registrants today get $100 off the 2-day pass. Just use the discount code BA Marathon during the registration. Visit Past BA Conference to register today. The discount code expires on January 1st. Next slide. If you are interested in accessing other free educational content, the PASS organization has a variety of virtual chapters which offer free webinars to their members every month. Check out upcoming webinars and recordings of past webinars from our Business Analytics, Excel BI, Business Intelligence, Big Data, and Cloud virtual chapters by visiting sequelpass.org/VC. Next slide. This BA Marathon session is presented by Ken Raetz. Ken is an enterprise business intelligence expert with over 20 years of business, technology, and consulting experience with focus areas in SQL BI, Power BI, and Excel. You can follow Ken on Twitter through Excel with Data. You can also reach out to him on Facebook and LinkedIn. Next slide. Without further ado, here's Ken Raetz, Data Extraction and Integration Patterns.
Great, thank you, Dan, and thank you everybody for attending today. I have been a part of the PASS organization for quite a while in the SQL Server side, and have in the last couple of years been a part of the PASS Business Analytics conferences and content. And it's exciting to see the audience grow. It's exciting to see the attendance grow, and really the variety of skill sets and roles that are represented in the chapters and in the organization. So today, what I want to do is talk a little bit about some secrets and techniques that have long been used by enterprise IT and programmers and developers that I believe can apply very well into the analytics and data and integration concepts and projects that many of you work on. Now, some of these approaches and techniques could very well be familiar if you come from a programming and more technical background, but hopefully you'll see some very specific ways that these techniques can be applied into the realm of analytics. And we will finish up with some demos. So we'll be about half the content today will be demos, and we have 3 demos. One is in the SQL world, so most likely as an analyst you spend time working with SQL, writing SQL, and so show a little bit on how these techniques can be applied in the SQL world. And then we'll spend some time in Excel with Power Query, and having just heard, if many of you attended the Chris Webb webinar just prior to this, he is a great source for Power Query learning. So if things that you see here you want to learn more about, he has a great blog and a book on Power Query, and it's just a great resource for that. And we'll end up with PowerBI.com and the Power BI desktop and learn how we can apply these techniques here. So programmers have long carried, it may be overstating it, calling it secrets, but there are techniques and approaches that allow programmers and architects to attack a problem that requires a significant amount of programming to break it down in such a way that it's more easily solvable and it achieves a few things. So the idea is divide and conquer, and the idea is to basically break a larger problem into smaller solvable problems that can then be repeated. So it typically comes in a very structured format of programming, which is where we come up with the modular approach. And you typically see this played out in techniques such as sequences or loops. So if you've worked with any data tools, you've seen some of these techniques implemented in those tools. If anyone here has used SQL integration services, you've seen the loop concept implemented there. If you've written SQL, you've probably written a loop or two. There's a concept of recursion, which is a little more compressed and perhaps elegant way of implementing these loops. And it provides a few things. It provides reusability. It provides a way of organizing the work that you're doing in such a way that you can more easily solve things and keep up with and maintain the solution over time. And the idea of black box in the world of programming is where you isolate a particular area of functionality and either delegate that area for another programmer to program, or do that yourself, but it allows you to basically focus on the thing that you're working on at that moment and know that there will be a task, a function, some kind of capability that you can call on to do a certain task, and we call that the black box technique. So it allows you to focus on what's right at hand and leave everything else to different parts of the program. So these secrets, these approaches, have been implemented through large programming projects and capabilities, and so we want to see how this can apply into the world of analytics. So there's one particular example, and this example is called the Towers of Hanoi, and it's something, I come from a computer science background, and this is one of the first things you hear about as you start learning is the Towers of Hanoi, and it's an approach where to solve a problem, you basically break that problem down into smaller problems, and it could be 5 smaller problems, it could be 10, but you basically continue solving each smaller problem until it's finished, and then ultimately the larger problem is solved, and it involves recursion and the looping. So the Towers of Hanoi, you see basically it's a set of disks that have to be transferred from one spindle over to the last spindle, and the rule is you can never stack a larger disk on top of a smaller disk. And so the programmers that came up with the algorithm, basically every time they went to solve it, they just simply created a smaller problem out of it and created smaller stacks until eventually a program was able to be written where it essentially looped through the stacks and got it over to the far side. So programmers learn this early on. Breaking that problem into smaller problems is a great technique to be able to do that. So then you start wondering, well, how does that apply into other areas? So you're going to see as you start working with large data projects and trying to deal with large, especially complex data issues, that you can actually start running into some pretty significant challenges. And one of the things that the structured programming techniques allow you to do is avoid creating long code. We always call it spaghetti code. Avoid creating content and programming that basically is hard to maintain. And so we organize the code, the programs into logical blocks and routines and loops. It also allows us to then parameterize. So you turn what might otherwise be static single function type code into something more dynamic that's reusable. And it supports collaboration more. So very often in a large project, you have to delegate the tasks and then find ways to roll those delegated tasks or programs back up into a single functioning routine. So these concepts then can be applied as we step into these other areas. So you see this concept sort of diagrammed out here where you have a main routine and it steps into each routine and then subroutine kind of rolls back up. and steps into the next routine and so on. That's the idea around structured programming, and that's what we want to apply here. So I'm on a bit of a mission, and I have watched the group here, both in past business analytics organization as well as other organizations, and I've watched the need for more enterprise approaches be required for analysts and power users. And typically, IT organizations, due to the types of skill sets that are there, they typically either hold on to those sort of approaches and techniques or have the tools available to them that allow them to do those techniques. And so I'm kind of on a bit of a mission to transfer those enterprise skill sets and techniques over to more power users. So I've been talking about a role, the analytics prototype solution specialist, call it what you will, but the idea is someone that sort of stands in the middle between IT and business, really understands concepts in both worlds and can apply them so they can develop solutions rapidly, they can design early prototypes that can then lead to more complex engineering of larger solutions. Of course, they understand the business, they understand the metrics, how to speak and define and map into the business world. But they also have to be able to, as they develop solutions in the analytics world, they have to be able to define vision, they have to be able to create the ROI because there's spending involved typically. As you're working through analytics and building solutions, you're going to come across data quality issues. And this is, I think, really where you start to run into some of the main issues where we start to see the need for maybe a different approach, a more, perhaps a more modular approach as you hit these data quality issues. So this is kind of why I'm speaking on these topics, is I have a mission to sort of transfer that skill set back over. You hear Chief Executive Officer, Chief Information Officer. I'm thinking this role might be Chief Data Wrangler, and we want to pass that on. So let's look at why analytics might require some of this enterprise agility. So as you're working through the data complexity, of course, the volume is higher, the complexity is higher, things change rapidly, and so you have to be able to be agile, but at the same time, we've seen techniques applied with people that don't have those enterprise skills. Those techniques then get applied and are very difficult to maintain, very difficult to come back and apply changes to, and very often apply incorrect approaches. And so what we want to be able to do is have that agility, have that enterprise capability, maybe not stop and address every issue that you come along with as you're working with data, but be able to move very quickly and apply a higher level of techniques. So what does it look like then to say modularize the analytics approach? How do you take analytics and actually follow a pattern that I refer to as some of the secrets of programmers? How do you do that? Well, what I see is that with data integration, and there's several, I would call, stages to this with integration and visualization, they follow patterns as well. And taking these patterns, we can actually apply these techniques into and using the tools such as Power Query, Power BI, and even SQL. And we can divide our problems into smaller parts and achieve these same outcomes with the reusability and reducing the complexity. In some cases, you'll find, especially as you're working with larger data sets, that you can also improve performance with these modular approaches. So let's talk about reducing the complexity. So typically, as we start working with data, we're going to get some input of data. We're going to go through some kind of process, and that process, it might be simply renaming columns and adding a few fields and calculations and then passing it on to the next step. In other cases, that processing might involve bringing in data from a cloud solution, from the web somewhere. It might involve bringing in files, database tables, doing some scrubbing of that data, and then sort of merging all of that together. Now, if you've ever been a part of an enterprise programming team, development team, you've typically had access to tools that would allow you to develop this way. So again, I'm not saying anything new to those that have been a part of those teams. However, when you are working on a single output, perhaps some kind of analysis around sales, perhaps it's a pricing model, you're looking at some marketing data, the process itself could potentially be so complex that it is difficult to run, and in fact some cases may not run. So what are some of the approaches that are typically used? People might build multiple Excel workbooks, they might build temporary tables and run a series of steps and load the data through that way. And while that can be done, what you may typically find is it starts to become difficult to maintain. So what we want to do is reduce this complexity in the process. And how we do that is we just start thinking of each of these pieces of the processing as steps. So just like the Towers of Hanoi, the divide and conquer approach, we take a smaller input, some piece of the process, a step if you will, and we then do some smaller processing on that, and then we see that there's an output to that. And I'll show examples of this in each of the three tools to make that more clear. But that's the idea. And then, of course, the next step, we do the same thing. And the idea is we break that down into smaller problems to solve. Eventually, what we end up with is something that looks a little more like this, where each of these problems are being solved in the middle, and then eventually we have our output. Okay, so that's conceptually what we're wanting to accomplish. Okay, so we see three areas in modularizing analytics, and we'll discuss what each of those three areas, kind of the subtlety and uniqueness of each one, and how you might approach modularization there. The first area is, of course, extraction. So we have to get the data, whether it's, again, from a database, from a file, from a website. It might be manually entered somewhere. We have to extract that data, and there's some techniques that we can apply accordingly. Then there's the transformation, the processing, the manipulation of the data itself, the cleansing, the combining with other data. All of that happens here. And then there's the visualization. So there's lots of tools for each of these different stages. Sometimes all of this is done in one location. Again, if you're working in Excel, you might import data, manipulate it, and then show it inside Excel. Other tools have different ways and have that divided up a little more. But we see these three areas as as a way to break that down and modularize analytics in each of these three stages. So let's look at each of these stages and how we can modularize those. So first we'll look at extraction. So the first thing, of course, the concept of staging has always been around for again, people working on development teams, building integrations, building data warehouses. The idea is get the data quickly, and this is important on a number of levels. It's important because oftentimes it's tough to get the data, so you kind of want to make your ask as complete as you can and then get it and then do something with it. And oftentimes there can be a performance hit on the source database, and DBAs aren't real fond of people spending a lot of time in production databases writing queries. So you want to stage the data, get the data out as quickly as possible. Another thing that can be used is views. So if you have worked in the SQL world or even Oracle, you know that there's a concept called views. If you've worked in Access, you've written queries, and the idea is define some kind of extraction definition, a query, and give it a name. And that name then can be used just like a table, just like another data source. And in here, you can basically add, rename things, add calculations, kind of mask some of the complexity there, and then that complexity can then be used later on. Another very common way when doing data extraction, especially if you're going against an application that has a lot of logic kind of buried in it, is to call stored procedures. And so whether you have a subject matter expert on the database there that can assist you with which stored procedures, another trick would be running existing application reports and running a trace or profile on the backside and seeing what the stored procedures are. But the idea is it's another way that complex logic has been embedded and then can be reused by the next step and kind of simplify what you're doing as you go to the next step of analytics. And lastly, of course, with files, very often you're going to get data in the form of files. And I'm going to show an example today of a project where we were going to work against the database, but at the time we did not have access to the database in our analytics environment, in our Excel and Power Query environment. So we ended up getting extracts of the data and then basically building our analytics using the files with the intention to come back through and point it back to the database. And so we'll talk through that. So that's the idea of extraction around modularizing analytics around data extraction. The second step is transformation, and very similar in the process of staging data, of loading data into tables. You can update that data in a variety of steps. Not a very common approach as you've loaded the data to update columns, apply calculations. I mentioned the views with the data extraction, and really a concept from that would be then building views upon views. So it looks like you've got a number of tables when you go to do your processing, your analytics, but the idea is you have a view and then a view on top of that and a view on top of that. So it's, again, another way of layering the complexity. Again, you may then, through the transformation process, have such complex logic that you build stored procedures there in the SQL world, or CTEs, which I'll show there as well. Okay. And lastly, on the visualization side, then as you're developing the content, you're going to need output. You're going to need formulas and calculations to display as part of your visualization, whether it's a metric of some sort. You'll need those. So through the use of tools like Power BI, Power Pivot, you can create those calculations and use those. You can then, of course, define the views or the tables within those tools and be able to visualize that. And another technique, again, is the use of reporting tables, the idea being that you build a table with a layout that you need. So the extraction, transformation, and visualization, we kind of see those three areas, and it's just to recap the different ways that you might use the modularization technique in each of those areas. So what I would like to do now is I'm going to hop over and we're going to do a little demo first with SQL. So bear with me. If you don't spend a lot of time in SQL, that's okay. As an analyst, if you haven't really become super proficient with SQL, you will want to. You'll find that your ability to do analysis will grow as you do that. So what I'm going to do is show an example of how you might modularize using SQL. And we will jump over here. And the idea is if you're working in the SQL Server world, you'll be very familiar with a database called AdventureWorks. And it basically contains sales, orders by product, by customer, and it allows us to really have a pretty clean database across that. And so I've given an example here where I would like to produce a listing of all products and their last order and the highest order amount that they had. And so that's kind of a complex thing because there's not a flag that basically, there's not a field that tells us, hey, here's your order with the highest amount, and there's not a flag that says here's your order which occurred on the last date. So what we do know is that we have some tables, product, and we'll use product, in fact, internet sales, where this product relates to internet sales, and we know very quickly, if you've used SQL, you know that there's a technique to aggregate data, and by product we can quickly see what is the last or highest date. And so you might say, okay, I could write that query and I can see by product here was the last order that it appeared on. However, now I have to go answer another question, and that other question is, let me find the product and the highest order that it was on, the highest order total. Okay, so that could be another query that I could then write, which here's the product and by order the total amount on that order. Now the challenge is, how do I start to take that next step? You can see the problem kind of growing because I have to answer one question And then I have to answer a second question based on that first question. And the first question is, what's my total amount by order, by product? And then what's my order that has the total amount, the highest total amount for each product? So here we're able to implement a couple of techniques. Now, if you've worked in SQL, it's very likely that you've implemented something like this through the use of temp tables. And that is a way of basically taking the output of a query and temporarily storing it for use in later queries. And that can be a good technique potentially. The challenge can be it also uses storage. It requires some permissions, and it could potentially have a big impact on the system. So I want to introduce something called CTEs, and this will be a real cursory glance at what CTEs are, and that is a common table expression. And it's a great way to develop a single, concise approach to building modular queries inside SQL. And basically the idea is I'm going to write a query, and I already showed you this first query, the select to get the last order date, and I'm going to give it a name. It's kind of a logical name, sort of like a view, and it's called last order. And with that, I could write a query that just says selects everything from last order, okay? And so you would see basically just like what I showed you before, that output by product, last order date. But what I can do with common table expressions is I can create a series of these CTEs, these queries, and name them. And then I can use them, the ones that are above it. So here I'm going to create one, orders by sales amount, which I showed you earlier. And then I'm going to create another one right here, orders by sales amount, uses orders by sales amount called highest order amount. And it's going to get the one with the highest order amount. And then right below that, I'm going to write a query. And so you see how I'm able to reference the previous CTE name, in this case highest order amount. I can reference it as though it's a table. So it's a great approach. I haven't stored anything. It's all virtual at this point, and it will run it dynamically as I run this entire query. So I've created a series or sequence of these queries. So at the very end, I'm able to write a query that references all of these and says, give me by product the query with the order that has the highest amount of sales, and tell me what the last order date was. And run that entire query, and I'll get one row per product with that last order date and the order with the highest sales amount. Okay, so this is a sequence of queries. Again, I haven't stored any data anywhere, and now I can either embed this into a tool and run it. I can, of course, if it's just a one-time thing, I can extract the data out, save that. But the idea is I have modularized, I've built query after query and developed that dependency at the end where I can call all of those queries and get my output. Another example inside SQL which I've mentioned is the idea of views. So a view is basically a physical database object. It's a definition in the database that is a query that returns a result set of some sort. And you can do all sorts of things in views. You can create calculations, you can filter data, you can have subqueries, you can do a number of techniques that can become pretty complex. And so you can embed a lot of complexity into a view. Why would you create a view versus write the query? Well, back to the maintainability that I mentioned early on in this talk, it's really important for you to develop content that has a longer view in mind than just that one analysis. So this view might actually be very useful for future analysis. It also might be that the view has to change, and if you've embedded the same query over and over and over again in each of your analysis and have to come back at some point and change the logic, you have to do that in a variety of locations. So here you're able to encapsulate that logic into one place. I've created an example. So again, with the AdventureWorks data, there's a table called employee, and it lists all employees in the database. They're partitioned by department, which is a field. Department name is a field on the table. So what I can do is here I'm creating a view called engineering employees, and all it is a query off of the employee table where I've filtered by department equals engineering. So now, when I go to query or analyze, do whatever I need to do, now I've got immediately a named object in the database. For all practical purposes, it looks like a table, acts like a table. I can further group and filter by fields in this output. But now I can run that, and it will always give me the engineering students. And so if any new students come in, I'll get more data next time, etc. So either CTEs or views, they're a great way in SQL to create that modular approach when doing analytics. So just kind of summarize here, I showed you the views, I showed you the CTEs. There's a lot to learn about that. Again, I'll reiterate, many of you may have deep experience in SQL, and so this is very familiar to you. But kind of for the rest of us, the rest of the folks that maybe don't use SQL quite as much, these are great techniques to use, and especially the CTEs, because when creating a view, a function, or a stored procedure, it requires you to have certain permissions on a database to be able to create those objects. With CTEs, they're more of a virtual query and a virtual way of creating that modular approach. So it gives you the ability to embed that logic and then to keep reusing existing business logic. So that's the SQL approach. Again, these techniques have been used for some time. What I want to jump over to now is how we would do this in Excel and Power Query. And again, part of my mission here is to kind of communicate some techniques here, and as people spend a lot of time in Excel and Power Query, you know, how can I apply that similar approach to something that I might be using every single day? So here's an example, and this is kind of a before example, where it might be a typical Excel analysis where there's a number of data sources, and in this case we've got tabs for each of the data sources. You can see here, okay? And those data sources are imported or connected to data connections, and then a series of tables, or in this case, formulas written to look up data in those tables, okay? And so that works okay. It just creates kind of a more cumbersome, sort of complex approach to building this, loading this data in. You've got a table here, you've got a table here, and so on. So we'd like to sort of shift that and take a different approach and organize this more in a modular way. So I'm going to show you a technique here, and we'll look at the Power Query itself. So here's a different workbook, kind of an after approach, and I'll show you the data. We've got these files. They're basically book sales and book information. And these files are going to be sort of the raw source of data that we bring in, okay? And what we'd like to do is be able to sort of isolate that extraction versus the transformation and the visualization steps, if you will. So here being one of the files we used, we created a Power Query. And for those that have not, are fairly new to Power Query, again, I would encourage you to spend some time. There's a good community, very strong community growing out there of Power Query. You're going to see some of the techniques here, and it may be a little tough to follow, but let it whet your appetite to go and spend more time in Power Query. So I'm going to edit this query here, and come back. And inside the Power Query, there's just a series of sort of steps in that Power Query of transformation. So we got the original data, which was a file. From that file, we manipulate and we tell it the first row are actually the file names, and we do some file type manipulation. But other than that, we don't do anything else. Okay, we're not doing any significant transformation. One of the reasons we did this is because I mentioned earlier, this is actually a scenario where while we have a file right now, what we actually ultimately will have is a database query. And for anybody that's spent time going from one source to another, what you'll find is the switching over to a new source comes with all kinds of challenges. Data types change, different things change. So the more we can isolate that to an extraction step, the more we can deal with those changes as they come. So this is just basically a straight up query off of that file. And you'll see that we've organized this. We've created these queries. We called them stage. Again, it's just the extraction queries, and we've organized them. So now I can start to bring, again, some of that organization that I mentioned to you early on. I can bring that to the Power Query environment. The next step here is then the process of referencing those Power Queries and then even doing some joins against them. So when I create a Power Query, I can actually, from that Power Query, reference it, and think of that as it's like a view that I can just simply select from. Okay? So here I'm going to show you what that looks like, and here it's a source. We're going to change the type and then do very little here. In other queries, we actually did a little more of the manipulation or transformation. Our final steps then got more complex, and then if you've used Power Pivot, you know that Power Query is a great source to load data into Power Pivot. And so we've then organized the queries accordingly so that we have our extraction, we have our transformation, and then we have our loading into our model. And we call that the model grouping. And so you'll see here, again, the queries get a little more complex. Here we selected from that table, and that one's not quite complex. I'll do this one right here. And you'll see the source. We join to another table. We do some expansion of that table to get the data, and then we round some data. So there's a series of steps that the Power Query goes through, and what this allowed us to do is actually reuse some of these queries for further processes downstream, and I'll show you that kind of in a diagram what I mean. But it allowed us that reuse, and I'm a big proponent of always sort of pushing the functionality, the calculations, any of the transformation as far back to the source of the data as possible. So we want to be able to do that whether we're in Power Query, whether we're in SQL, or I'll show you here in a few minutes, Power BI Desktop. So the output of this then gets loaded into the model, and now we have a very clean model. It's not cluttered with a lot of tables. We have just 3 tables here, and those tables then can become a part of our analysis as we move forward. The data is much cleaner, and you've hidden a lot of that complexity. Okay, so that's the Power Query to Power Pivot sort of process. And a recap here for you, sort of what that looks like. So again, it's basically trying to figure out what are the stepping stones, what are the building blocks for a solution. And if you're ever unsure, just go ahead and create another Power Query anyway. And the reason for that is if you start running into data quality issues, it's far easier to trace those issues if you've broken this down into more Power Queries. You can find where that issue began to be introduced, if it was the source, one of your calculations, and so on. You can also functionalize Power Query, and there's a lot of good content about how to do that, meaning you can take a Power Query and make it dynamic, where you could actually call it and pass in a value. And I'll show you kind of an example of that on Power BI Desktop, and you'll see that very similar to how you would do it in Power Query. Also, with the use of a tool called Power Update, you can actually load the output of Power Queries directly into a SQL table. So if you've ever had to build analysis and the output of that analysis had to go back into a database somewhere, that can actually be enabled through the use of Power Update. So this is kind of what it looks like sort of schematically. When you look at your staging data, your source data that you're extracting, the idea is let's sort of map that, create separate Power Queries, do the transformation, and you can see then kind of some of that reuse or the linking that happens through the transformation process. And now let's then build the visualizations. You can see through that transformation process the same Power Query is used in 2 different downstream Power Queries. It might be a lookup table, whatever it may be. So this is conceptually the idea that you want to use and implement in Power Query, and it'll make your life a lot better. It'll actually make maintaining the solution a whole lot better. So the last thing that I want to show is Power BI. And how do we use this in Power BI? And I'm going to show in particular the Power BI Desktop. So if you have not, let me jump over here. If you have not been introduced to Power BI Desktop, and PowerBI.com. I highly recommend you do this. So if you've been using Power Pivot, Power Query, or even if you haven't, PowerBI.com is a great place. It's free. There's certainly a paid level, but there's free access where you can go and do some pretty complex analysis, do a lot of data collecting, data integration. You can see the ability to do a variety of very highly visual representations of your data are capable here, and then of course to publish that out to the website, to a cloud solution, PowerBI.com. So what I'd like to do is kind of show you an example here in Power BI Desktop, and this one involves some web data, some cloud data. So I'm going to hop over here to a site, and this would be the Social Security website, Popular Baby Names by Decade. So if I was looking for that and wanting to, think about either naming my child or recommending that to somebody else, or even was requested to do an analysis like this, how would I go about doing that with a site that's out here that has data? I'm going to pick a decade and check out what that data comes back as. So here I've got top baby names, boy and girl baby names in the 2000s. So basically I've got it by decade. So can I actually get access to this data, and can I turn this into a result set that actually is usable? That's kind of the question that we have to us. And the idea is we can kind of see a pattern with this site where the site name has the decade embedded in it. You see the 2000s. It has the ability to pick it, but that becomes a little more complex for more of a programmer's job. We want to do this just through this process of extracting data. So what we're going to do is we're going to start on that particular, we'll go back to that particular page, and we're going to get that web address right here, the names2000s.html, and we're going to create a new data set. Okay, so we're going to get data, and we have an option in Power BI and desktop, and you'll see this very similar interface for Power Query, where I can extract from a web source. So you may say, well, is this a web service? For those that are familiar with APIs, is this a RESTful web service? This is a web page, is all it is. And it's going to go out there and kind of examine the web page and say, is there data out here that kind of looks like a table? And sure enough, it found this one, and it actually retrieved the data in a tabular format. And you say, wow, that's remarkable. I can actually do something with that now. And so I'm going to choose that particular data set. I'm going to edit this, and it'll open it up in my query editor. And then from there, I can do some manipulation. I can actually eliminate that null row because that was something that was kind of meaningless. I can make the first row here become the headers, become the column names. It makes it a little easier to manage the data. And so each time I do this, just like Power Query, it's applying a series of steps. Now the challenge becomes, how do I turn this into a set where I can look at baby names for boys, I can look at baby names for girls, and so on. So you could carry this a little bit further and essentially remove these, add a column that says these are boy names. Okay, so this is just kind of the brute force method. You could add a column that is the decade, and it was the 2000s, right? Now, how do I go from there to having the entire set of data for analysis? Well, inside Power BI Desktop, the get data function, as well as Power Query, you have the ability to append queries to each other. So in the SQL and set-based world, we call those unions. In Power Query and Power BI Desktop, they're called append. And so we could take this query and essentially duplicate it and change it to go get the page that was the 1990s and the 1980s and so on, right? We could do that. And then we could go change it so that it returns the boy columns instead of the girl columns. So kind of taking that approach, I'm going to jump over here to a query that we finished. we sort of did that a little bit, sort of removed some things and ended up with two data sets. That was the decade, the girl, and so on, and the boy names, and then a query that combined those. It's a very simple query where you take one source and you append it to another using that append function. And so here we've got an output set that has boy, girl names for one decade. And again, we could then take that and append it with each of the decades, but we saw a pattern here. We saw a pattern where we could actually solve this, making it a little more dynamic. And the reason why we're able to apply that pattern is we see that there's sort of a separation of duties here. There's a modular pattern that can be applied that we want to take into account here. So what we did was we took one of these queries, and if you look, as you build a query, behind the scenes it's actually building some code, and that code shows up here. And it's okay, you don't have to necessarily know everything about it, but it's a highly functional language, what was called the M language, highly functional language that you can actually make more dynamic. All right, so you can see here in our source where we go after the name, the website, it has that name, that decade embedded in it. You can see here down in the query where we actually eliminate the columns, the column 1 and column 2, or column 4 and column 5, because it was a boy or a girl. So basically what we wanted to do then is take that and then turn it into a function. So through Power BI Desktop and Power Query, I can take that code, open up and create a brand new query, and I'll show you the result of that. And all you do is you put this part at the top, and again, if you just Google Power Query, parameterize, or function, you'll see a lot of examples. Again, Chris Webb and others, Ken Poole and others have a lot of great examples. But the idea is I would like to create this query where I can pass in the decade and the gender, and it will then automatically go to that page over and over and over again. So you can see here that decade I've embedded as a little formula. It's just a kind of a concatenation operation, if you will. So I'm manipulating the name of the URL that's going to be called. And then later, I'm looking, if the gender was boy, then I want to get rid of the the girl columns. If the gender was girl, get rid of the boy columns, so that my output ends up being the entire data set for either boy or girl for whatever decade I passed in. Then I can simply invoke that. So you could see I can kind of test it out and say, well, go test out with the 1890s and with boy, okay? And you see that I get 1890s boy and so on. So it becomes a highly functional way to do this. And now the question is, how do I sort of create that loop concept? So modularizing the data, how do I create the loop concept? And so we've only got a couple more minutes. We'll make these examples available to you. I wanted to kind of show the output, the final result here, and that is, clear that out, and that is basically this final query right here. So what I've done is I actually went out and grabbed a table that listed the decades. So you can see the output of it here, 1880s to 2000s. Again, that actually came from a website. And then I created an output from that where I called the put it right here, and we appended, oh, I'm sorry, baby names by decade. Oh, here we go. Source. And go to the advanced, and where did I go? Here we go. And so the function call ends up being basically adding a column, adding a call to that function that we wrote, and essentially with each decade, it'll call that function over and over and over again. I could have done the same thing, combining it with the gender, boy and girl. So the output ends up being the entire set of data. And you can see what I've done is I've organized this in the same way where I know that, well, I've got some extraction data, I've created some functions, there's some processing, and then here's where I'm actually loading, so that my end result can actually be let me go back here, my end result can actually be then a very useful model where I can do some analysis. I can start to change the output in the way that I want to view that, manipulate the visuals, etc., because I was able to deal with the data and the integration issue itself. So hopping over here, just kind of a highlight. Essentially, very similarly, we created a Power BI query for each step. We used the duplicate or reference to basically use that for our next step. And in cases, you may actually end up needing to use tables and views there too, but the idea is you can still create that same modular approach, you're just in a different tool. So lastly, I want to say this on collaboration. So one of the things I mentioned was the use of modularization in analytics really opens up the door to collaborating on analytics projects. So you can see now where using that idea of black box, you know that you need something done with this piece of the data set. You can have somebody go work on that through Power Query, through Power BI Desktop, even SQL, and then hand that back up. You get everybody involved. It makes it easier to iterate through, and you may even find through that process of collaboration that you even have to kind of hard code some rules to move on, but you can always come back to it because you've maintained and organized it well. So that's the idea of modularization with analytics, and hopefully you saw a few examples of how you could do that with the different Microsoft tools, which is what we work in a lot. And again, they shouldn't be secrets. They shouldn't be secrets on, they're kept to the IT groups. Apply these, make complex solutions, get people involved, and I think you'll find the world is much more enjoyable in analytics. So thanks for your time, and at this point I'll hand it back over to Dan.
All right, Ken, thank you so much. That was great. We're ready for some questions now. If you have some questions, just remember on the right-hand side there, you can go ahead and enter in a question, and we can ask that to Ken here. We do have a few already queued up. So first one here is, does the data refresh work fine in the Power Pivot model if it uses a Power Query data source?
Yes, it works great actually, and so I'll caveat that. I know there's a number of Excel versions in operation out there. Excel 2013 is how I'm answering this, Excel 2013 and above. But Power Query is a great source, and they're very integrated between the two, Power Query and Power Pivot, so it refreshes very well.
All right, great. Next question, Power BI is free to use. How do you then share it without an account? I'm assuming they're referring to the desktop application. They're wondering if you can't share it without an account, is it really usable?
Well, so you have to, I guess I'll answer it this way, and admittedly, this is something that I think the people in the Microsoft camp, us included, are very hopeful for how that functionality will expand and how it can be shared. And I think Microsoft has shared a good bit on Power BI's roadmap where you're going to see more sharing, more embedding coming down the road. But today, the personal Power BI edition is definitely geared toward the individual analyst. You can share a dashboard, but there's just some limited sharing capabilities, and again, you can't embed it. Once you go to the paid version, the $10 user per month, it's easily shareable within people in your organization with the same, essentially the same domain, the same company. So.
All right. They're wondering about, in your Power Query example, is the looper code in the M language? If yes, then how is it different from a do-while loop?
So the loop code, and what I actually showed there was a little more of a set-based function versus a loop, and you can certainly loop. So the idea here is instead of create, which is more of a sequential approach, meaning, okay, here's one record, go do this and loop through, and then the next record and so on. What we did is we created a function that could then be called, and when you call it, you can actually call it from the join from another table. So let me just, I kind of skipped over that real quick. Let me just show you because it makes it far easier to understand. The idea is I want to take a table like decades, and I want to be able to make a call to that function from decades. And so from there, I can actually add this calculation, and I can get the, let's see, what do we call it, baby names by decade and gender, which is the name of my function, and I'm going to pass in my decade, and I'm just going to pass in boy for now. Okay, and what that will do is actually it like creates a join or a merge with that data set, and it says, hey, that's a table. What do you want me to do with that? And from there, I can then expand that, and so that's how the function gets called. So now I had my decades, which has all of those 1880s, 90s, etc., and I've got all the data. It made a call over and over. It essentially did a loop, but it did it from a data table rather than writing a loop code, if that makes sense.
All right, and just want to let everyone know that these sessions are being recorded today, so those will be available for you to view after. And the presentation material is already available if you go to the webinar registration page and log in. All the presentations, all you got to do is click on the name of the presentation and you'll get the resource there. All right, another question here. Someone is inquiring if you have any books or websites or resources that you would recommend to learn more along these lines.
Sure, absolutely. So again, Chris Webb, and it's not really an intentional plug. I was originally not scheduled to be in this slot. It just so happens that he's a big favorite of mine. He has a lot of great content on his, so look up Chris Webb, 2B's, Power Query, and his site as well. Ken Pools is a great resource. They both have good sites out there. Excel Guru, I believe it is. No, Mr. Excel is Bill Jelen, Excel Guru. Anyway, those are two guys. So Bill Jelen, Ken Pools, P-U-H-E-L-S, and Chris Webb are great sources, and they're covering the ground of Power Query, of Power BI Desktop, and its get data functionality as well.
So we had a couple people inquiring kind of along the same lines here. They're wondering at an enterprise level if you were going to use like the Power BI application or Power Query and use it against like enterprise type data where you have a huge fact table. Would you still recommend using this type of a tool?
Well, so yes, but I want to, I guess, caveat that by saying no tool, no matter how good it is, can open up a billion-row table and simply list the data. Most analytics are geared toward making big data small, and that's how I would answer that. So Power BI Desktop, the engine with Power Query and Power Pivot combined, are very good at doing that. Now, again, taking that modular approach, most of the time I would dare say that doing an analysis on a large enterprise database, there's going to be some kind of shrinking of the data through that process, and the sooner you can shrink it, i.e. a step in your process, the sooner you can shrink it, the better off I think your analysis is going to be. And I guess the last thing I would say to that, very often the approach we would take is to get a sample set so you can work on more of the calculations and the techniques, then start to work on the scaling with the larger set. So I'm not sure if that completely answers it, but I'm happy to expand on that if I need to.
That's perfect. And you did mention that you were going to try and make these files available for people. Do you have a blog site possibly?
Yeah, I tell you what we'll do. So if you'll go to, we don't have it up there right now, but if you'll go to the thinkdatainsights.com, and a quick way to put that up there, we'll have a blog out there with all the content that you can go download.
Perfect. All right. Okay, everyone, we got to wrap this up now. So Ken, if you could go to the next slide, please. Great questions, everyone. All right. So you like what you heard today here? Ken will also be presenting at the PASS Business Analytics Conference next year in May. The presentation will be on driving data quality initiatives with Agile Analytics. Next slide. This Business Analytics Marathon is brought to you by PASS, a not-for-profit organization which offers year-round learning opportunities to data professionals. If you're not a member yet, join today. The membership is free. Just go to sequelpass.org. next. Stay tuned for our next session, Creating Outstanding Spreadsheet Models with Jordan Goldmeyer. Thank you all for attending today. Great questions, and thanks, Ken, for presenting and sharing your knowledge with us.
Thank you, and y'all enjoy the rest of the marathon today.
Have a good day, everyone.